Okay, good morning. If people could come in and take their seats, we're going to start shortly. Okay, good morning. Welcome to IRTF Open at IETF 123 in Madrid. I'm Dirk Kutscher, I'm the IRTF chair. And so we have a really exciting but also quite a packed program today, so let's just get started. Just the usual reminders, we have the IPR note well, so let us know if you see or contribute any IPR related in a short time frame. This is recorded, be aware of it. And we are operating under a set of bylaws, so the privacy and code of conduct of the IETF and the anti-harassment procedures also apply to us. And this may be new to you, so the IRTF also has a code of conduct that is targeted a bit more also at ethics in research. It's a good idea checking it out. And yeah, just a reminder, so we will have Q&A sessions later, right? So if you want to ask questions, please use the queue system in the Mitico on-site tool. And yeah, I would like to emphasize that we are the IRTF, so we're doing research. We're trying to, investigate research questions, but we're not doing standards. And that's with that. I think we have finished the bylaw part. And so these are the 15 research groups that we have in the IRTF. And so I'm really happy to report that all of these 15 groups met or are still meeting this week. So it's been a really busy week for the IRTF, but I think it's a really good sign. And in addition, so we are constantly, discussing suggestions, new ideas for new potential topics in the IRTF. And so today, I think right after this, there will be a side meeting on like systems research for space communication and space system design. I really would like to encourage you to attend that if you have any interest in that topic. Because we just need feedback, input from everybody. And earlier this week, on Tuesday, we had a short side meeting on discussing, so are there internetworking challenges for AI that the IRTF should be looking at? So that was a relatively short meeting because we couldn't fit it in a different way. So the materials are online in a GitHub repo. My thinking is that this probably requires a bit more discussion, so we probably will have a continued discussion, maybe an upcoming IETF. There's also a mailing list, so if you're interested, please sign up to that. In addition, we are running a workshop on the same topic at ACM Connects, so one of the conferences under the SICOM umbrella. So this will be at Connects in December in Hong Kong on the HKUST campus. Okay, so just quickly, I mentioned it yesterday at the plenary, but so we have this diversity travel grant scheme, which is really helpful to help people to get to the IETF that would normally not be able to attend. So the deadline is coming up really soon, so we are trying to set it relatively early to give people enough time to get their visas ready and so on. So it would be very important if you are interested or you know anybody, please let them know. So the deadline is August 1st. And yeah, so on Tuesday, we also had the Applied Networking Research workshop. So I think it was really successful, went really well. So thanks again to Anna Bundström and Jan Beckett. Thank you. And so if you check out the website, you will already see all the papers that were presented. And yeah, so the main part of today is the Applied Networking Research Prize. So so we in every meeting we give out this prize. We kind of try to award the best results in applied networking. So typically we have a committee that identifies good papers that have been published. And then we are really happy that we have the support from ISOC, Comcast, and NBC Universal, and invite the authors here to present their work. So yeah, many thanks to everybody on the award committee. So it's a yeah, professional process. So we had 69 nominations and yeah, made 6 awards out of that. And yeah, it's my pleasure to announce the ANRP award talks today. So first we will have Harika Manda. So she will get the award for her work on analyzing internet access inequity. And then we have Hendrik Sech, and he will get the award for his work on Starlink performance measurements. And in addition to that, we're very happy to have Hermann de Meer here with us from Passau in Germany. And so after the award talks, he will give an invited talk on the mutual dependency of power systems versus information and networking technology. So this is the agenda. We can't really bash it much, but if you have anything else, let us know. All right, so then I'd like to invite Harika to the stage. And just a moment, I'll bring up the slides. You can stand there ideally, if possible, and let me just quickly announce you. So yeah, Harika is a PhD student studying computer science at the University of California, Santa Barbara. And she's also the recipient of the NSF's Graduate Student Research Award. She currently works with Professors Elizabeth Belding and Arpit Gupta, and is interested in how we can characterize broadband service quality through internet measurement and AI models. And now we are really excited to hear her talk.
Thank you for the lovely introduction, Dirk. So let's get started. Okay, again, good morning, everyone. My name is Harika Menda, and I'm going to be talking about our paper called The Efficacy of the Connect America Fund in Addressing U.S. Internet Access Inequities. This was a collaboration between my university, UC Santa Barbara, and UC Berkeley, and this paper was previously published in SIGCOM of 2024 last year. So let's get started, shall we? So presently, there's a real prevalence of internet access inequity, both in the United States as well as the entire world. In the United States alone, 30 million people lack access to high-speed or performant internet services, with around 40% of these people being present in hard-to-serve rural or tribal areas. This is often because ISPs, or internet service providers, are not incentivized to build infrastructure in rural areas due to a low return on investment. More egregiously, even if people have access to an internet connection, around 10% of the population of the US still cannot afford this internet connection due to often high subscription costs. This has led to a situation where there's a real marginalization of underprivileged groups and populations in our digital society, which is becoming increasingly reliant on the internet for day-to-day activities, such as applying for jobs or maybe even accessing medical records online. Even if we zoom out and look at the entire world, we can see when we're looking at the share of the world's offline population that a large number of these underprivileged groups are present in and around developing nations. That accounts for around 2.6 billion people that lack access to the internet. So what do we really do about this situation? Or more particularly, how can policymakers really influence internet access and make this situation better? That's why in the United States, Congress and the US government has historically instituted a series of multi-billion-dollar policy interventions in order to improve the state of internet access for all. The program we're going to be talking about today is called the Connect America Fund, or the CAF program. This started in 2011 and ran all the way for 2021 and dealt with around $10 billion of money. This worked by subsidizing new infrastructure by paying ISPs essentially in order to deploy infrastructure in rural areas that I was talking about earlier. However, there have been other initiatives such as the recent BEAD program that actually started in 2022 and it deals with 4 times the amount of money, or $44 billion. Given the amount of funds being allocated to this, it's really important that we try and understand the fundamental problem in this situation. That is the relationship between ISPs and policymakers. You see, policymakers really don't know whether addresses are actually receiving service or not. That's why they rely on ISPs in order to provide self-reported data about which addresses actually receive service. You see, if you believe in the integrity of the process, which I'm sure many of you do, you might think that this situation is okay and we should believe in the integrity of the ISPs. However, unfortunately, that's not the reality. ISPs often admit to lying to the FCC about the size of their networks in order to block funding to the rivals. I want to bring to your attention a lot of these newspaper headlines, including this particular one, including the state of Colorado, which is essentially a region of the United States, which was actually challenging 13,000 speed inaccuracies in the new federal broadband map that, you guessed it, relied on ISP self-reported data. So what do we really do about this situation? Or more particularly, how do we really reduce our reliance on self-reported data from ISPs about internet access? In order to do this, our team at UCSB decided to leverage our prior work that was published in SIGCOM of 2023. This was based around the Broadband Plan Querying Tool, or the BQT tool. Essentially, the BQT tool allowed us to scalably measure and see if we could interact with ISP websites and extract 3 dimensions of information about addresses. These 3 dimensions are internet availability, quality, and affordability. This is the first time we're able to access fine-grained information about broadband and their advertised speeds. The BQT tool is easy to use and allows us to extract CSVs such as this, which gives us the time for querying the address, the service status, as well as fine-grained pricing information along with the download speed and upload speed. So for example, if we run the BQT tool, we might get a response such as this. For a particular address, which I have blurred for privacy reasons, we can see that this address is actually receiving 768 kbps, or is also required to pay around $55 a month. We saw that many of these addresses usually only had one plan to select from. And in the case when the addresses had no option, our BQT tool really usually received a response such as this, where there was no service available to pay for. Now, how does the BQT tool work in the first place? Well, I want to show you that anyone can use it. Essentially, given a list of addresses, which are usually residential in nature, you can pair that with Selenium code from regarding an ISP, essentially. Together, these are deployed in a Docker container interface or a cluster. We also make the use of a VPN proxy. This VPN proxy is usually used to bypass anti-bot detection services that many ISPs usually employ because they would not like people to collect this data usually. These VPN services were actually provided to us by the Bright Initiative, so we sincerely thank them for access to that. So finally, using our Docker container interface, we're able to scalably collect serviceability and quality and pricing information and store it locally and securely at our UCSB servers. So now that we finally have our BQT tool, how can we really use it in order to assess the Connect America Fund or the CAF program's true success? But let's not get ahead of ourselves. Let me explain and introduce what the CAF program is about in the first place. So essentially, the goal of the CAF program was to address the real disparity in internet access, which was affordable and performant in high-cost rural regions, as I was explaining earlier. These regions often do not receive anywhere comparable internet speeds to urban areas. And how it worked is essentially the CAF program allowed the FCC, or the Federal Communications Commission governmental body of the United States, to subsidize ISPs to build infrastructure in these regions that lack broadband internet access. The phase one of the CAF program actually consisted of 6 million addresses scattered throughout the United States. And the FCC also specified a set of service quality agreements that ISPs were required to adhere to. This was actually a 10 megabit per second download speed and 1 megabit per second upload speed. And also, they were required to adhere to specific price requirements so that consumers were not overcharged. And finally, as for the certification process, as I was talking about earlier, ISPs actually certify these addresses through a self-reported framework that is actually not essentially public in nature. In order to impress upon you the scale of the CAF program, you can see this map of all 8 million addresses, which were part of phase 2 of the program. You can see there are regions all around the United States. And in its infancy, even the CAF program was extended among 37 states in the United States. So now that we know about the CAF program, how do we really investigate how effective it was in really expanding internet access, given that it dealt with such a large scale of funds and ran for approximately 11 years? In order to do this, came up with a set of key policy questions. The questions include as following. Question 1 is, are ISPs always truthful about the addresses that they certify as served? That is the 6 million addresses of the CAF program. Question 2 was, are these ISPs always compliant with the FCC service quality and rate requirements? That is the 10 megabit per second download speed and the 1 megabit per second upload speed. Finally, and most importantly, the major question was, are these regulated monopolies that the ISPs are essentially creating using the CAF program really offering a better value to users than the unregulated ones that would have been in place if the CAF program was not present? So in order to do this, using our BQT tool, we decided to create a data set to essentially do an apples-to-apples comparison between our certified self-reported data set that was provided by ISPs versus the advertised information that we're able to extract using our BQT tool. However, we ran into a problem where 6 million addresses was quite a lot to query, and we didn't know which ISPs or which addresses were the most important. In order to figure out this information, we did an analysis where we found that a couple of ISPs were essentially monopolies and operating and were in charge of essentially more than 50% of the CAF addresses. These top 3 ISPs were AT&T, CenturyLink, and Frontier Internet. We also decided to study a smaller ISP, such as Consolidated Internet, to see how they operate in relation to these big conglomerates. We also decided to select 15 states for geographic diversity, and we used a robust sampling strategy where we sampled at least 10% of the addresses from each of these census block groups. Given this robust sampling strategy, over the course of a couple of months, our team was able to create the first of its kind fine-grained data set of 687,000 street addresses, with 500K of these being approximately CAF addresses with fine-grained download, upload speed, and pricing information. So now that we finally have this data set, we can start to answer the key policy questions that I was talking about earlier. Let's see what happens. So the first question was, are ISPs really truthful about the addresses that they certify as served? This is some ISPs, by the way. After collecting data using our BQT tool, we saw that unfortunately there was an overall serviceability rate of only 55%. This is actually shocking because ISPs had certified that they served 100% of the addresses, and they had received funds for every single one of these addresses part of the CAF program. And when we desegregated this number based on ISP, we saw that AT&T had a pretty low serviceability rate of only around 31%. That is, only 1 in 3 addresses that AT&T was servicing as part of the CAF program actually received or had the chance to buy internet service in the first place. Given that there was such a divergence between AT&T and the other ISPs, we decided to investigate a little further. We saw that AT&T received around $1 billion, or 10% of the total CAF funding as a single ISP. When we desegregated these numbers based on states, we saw that several states actually received less than 31% of serviceability rates. One state that I want to highlight in particular was Georgia. We actually wanted to see where these serviced addresses stacked up in comparison to the non-serviceable addresses geospatially. Were they all in the same place, or were they clustered? As we had thought, unfortunately, we could see through this geospatial map, this is essentially a heat map where the dark blue regions indicate high serviceable regions where around 100% of these addresses were serviced. And these red regions, unfortunately, indicate addresses and census blocks that received little to no service. We can see that the high serviceability regions were concentrated in and around urban areas. This is a metropolitan city in the USA called Atlanta, which has a significant population and pretty good internet access already. And when we move to the remote rural regions, unfortunately, we can see that the internet service drops drastically. This is particularly disheartening because AT&T actually ignored the primary targets for the CAF program, at least in the state of Georgia. These were remote rural regions that were actually the reason for the allocation of the funding in the first place. So now that we answered the first question, let's answer the second question and see if there's any difference in our results when we take in speed into consideration. That is, are ISPs really compliant with the speed and price requirements, the 10 megabit per second download and the 1 megabit per second upload? And unfortunately, we actually observed an aggregate compliance rate of only 33%. That is, out of all of the addresses we sampled, only 1 in 3 addresses actually received the chance to buy service that was greater than 10 megabit per second download and 1 megabit per second upload. In particular, when we desegregated this based on ISP, we saw that AT&T and Frontier Internet were the worst offenders, with actually all ISPs offering substandard broadband plans. We saw a lot of AT&T addresses which received service were only receiving less than 1 megabit per second, or around 768 kbps. This is particularly egregious because in this digital world with dynamic websites and streaming videos, it's extremely hard to perform any sort of internet activity with that sort of connectivity. And in particular, given the drastic difference between serviceability and compliance between Frontier, we decided to investigate. We actually saw that a lot of users could not even choose any specific speed tier, and that even if users paid for a broadband plan, they could not guarantee any particular level of performance whatsoever. And they were in violation of the 10 megabit per second download speed and the 1 megabit per second upload speed. So finally, now that we answered our first 2 questions, we can start to answer our third question with respect to non-CAF addresses. That is, are the regulated monopolies that the Connect America program is essentially creating really better than the addresses when there was no Connect America program in the first place? In order to do this, we decided to focus on 7 states, given our large scale of data collection, and we decided to get our non-CAF residential data from a dataset provided with our partnership with Zillow. We also made sure to remove all addresses which actually received no service, as we wanted to measure and compare the speed between CAF addresses and non-CAF addresses. This is really important. So what we found was actually only in 27% of our observed census block groups did the CAF program actually have a real benefit and the users received better speed tiers than non-CAF addresses. When we decided to look into this 27% of census block groups, we did see something a little bit better. We plotted a CDF showing our percentage increase in average maximum speed for the CAF program. And when we look for 25% of the addresses, you can see that they had a percentage increase of more than 200 Mbps. This is quite significant for the user and showed that when the CAF program was actually implemented correctly, it had a real improvement for the end user. So now I would like to talk about competitive addresses. So as we all know, competition usually increases subscription rates. So we wanted to confirm this, and we actually plotted a distribution showing the scale of download speeds for addresses that were part of the CAF program and addresses that were not part of the CAF program, but were also surrounded by competitive ISPs. The ISPs we used for competition in our cases were usually Xfinity, Comcast, as well as Spectrum in our case. What we saw was that when we look at the top 25% of these addresses, until the 68th percentile, it's usually the same. But when we look at the 20%, you can see that the CAF addresses around competition addresses were essentially receiving better than 90 Mbps. This is quite significant. And to show you this information spatially, I'm showing, if I bring your attention to the right picture, you can see two block groups. One block group is really close to the other one, and they're essentially in the same area of the United States, that is Georgia. They're both serviced by CenturyLink Internet, which is a CAF ISP. However, there's an important difference. One block group is essentially a monopoly, with CenturyLink serving all the addresses and the users having no other chance to apply for a different ISP, whereas the other block group has CenturyLink as well as a competing ISP right in the vicinity. And we see where there is competition, there's a humongous increase in the download speeds, with often more than 6 times in this case. So what did we learn from all this? And let's try and revisit our questions and break down whether we actually have our answers. So our first question, of course, was, are ISPs really truthful about the addresses that they certify as served? And unfortunately, no. Only 55% of the addresses we actually surveyed received real service from the ISP that they had funds for. And question 2 was, are these ISPs always compliant with the FCC service quality and rate requirements? And unfortunately, we saw no. The overall compliance rate for our service quality was only around 33%. And for question 3, well, I wish I had better news for you, but unfortunately, the regulated monopolies did offer a better value for users. However, it was inconsistent. It was only in 27% of the cases that we saw. So what do we do with all this information? Well, I would like to impress upon you, this was actually, at the time of its publication at least, one of the first large-scale analyses of multi-billion-dollar broadband programs involving ISPs and their certifications. And I'm really calling for a post hoc and more thorough evaluation framework in order to certify the ISPs are really compliant when receiving money. And finally, I wish the process of the certification is more public and transparent for the benefit of policymakers as well as the end users who are the real ones suffering. Finally, as for current and future efforts, we're currently working to expand our broadband plan querying tool, or BQT tool for short, to more ISPs. We're also working with other state and local government organizations, such as the state of Virginia, as well as California, which are all regions of the United States. We're also working to assess other policy interventions as well, and we're working with other research institutions, such as Pew Research and the ILRS. We've received a lot of press coverage, including a Harvard Law Review blog, which looks at this from a more policy-based perspective, as well as the Internet Society blog post. We've also submitted a U.S. Supreme Court brief in support against Wisconsin Bell, which is essentially a subsidiary of AT&T. The results of the Supreme Court brief came out, and essentially the Supreme Court ruled unanimously in favor against the subsidiary of AT&T, essentially. So thank you all for listening. I extremely appreciate it. My name is Harika Manda. You can find me and email me about any questions at hmanda@ucsb.edu. We also do numerous studies like this at UC Santa Barbara, and you can find our website at address.cs.ucsb.edu, and you can even scan the QR code link. Thank you for listening.
Okay, we do have time for questions, and I see Corinne in the queue.
Good morning. Hi, Haruka. Corinne, Article 19, which is a human rights NGO focused on freedom of expression. Connectivity is a huge issue for us, also something that we work on, that we do research about. So first of all, I just wanted to commend you for the research, both the quality, but also how brave it is to be doing this kind of work, especially after everything that happened in 2025. My main question right now is actually twofold. What has the reception been in terms of the local policymakers that you work with right now, in terms of what they can and cannot do with the findings? And then the other thing that I was wondering about is what is next for you? What is the next piece of exciting research that we can see you doing right now?
Thank you so much for the question. So as for the current work we're doing with policymakers, so essentially in the US, we have a federal broadband map, which essentially is based on ISP self-reported data. So a lot of these local governments want to challenge the ISP self-reported data using the BQT tool, essentially. So this is the first time people have access to data other than what ISPs give to. So that's mostly what we are doing with local governments, which I feel is extremely beneficial and important work. And finally, as for the second question and what we're working on, in addition to expanding BQT and making it more scalable, we're actually trying to look at the other dimension and seeing if we can look at internet performance and measurement tools to see what's really happening to the end user. Because as we know, even if we pay for a subscription, we don't know if that's exactly what we're going to get. So we're looking at the best scalable and lightweight measurement tools that we can bring to the end user. Yeah, thank you.
Hi, Haruka. This is the second time I'm seeing this work, and it's
Yeah.
much more clear the second time around, so great. Since we're at the IETF and the IRTF, I'm going to ask some, I think, challenging questions, not just for you, but for Dirk and others in the room. One of them relates to slide 16, which is the deployment model. And I will tell you, because in a former life, I actually spun up one of these ISPs, backhaul ISPs, and the common practice, and this is around the world, for the large operators, even if well-intended, so setting intention aside, is when they move to the rural areas, they will focus on the center and they effectively cut out the economic heart, making it unviable to deploy to the people who are just outside of the little town center. And that might be worth looking at, right? The effect of cutting out the economic heart of a community. The second one relates to slide 10, talking about observability. I actually wonder if there isn't an opportunity here for the IRTF and the IETF to think about this source code, little icons on the left, how to maybe standardize those or generate recommendations so that policymakers around the planet can require that it's easier for source code to interact with the websites and get information when public money is involved. Lastly, and I think this is a really open one, Dirk, there are a couple of drafts that are out these days we could argue actually make this situation worse. And what they might end up doing is extending the lifetime of old capital expenditure in the form of copper and delaying new infrastructure. So it would enable money to be spent on the wrong things, and we might get worse outcomes. And it would be really lovely if we could sort of project and predict maybe the effect of some of these drafts that are out today.
Okay. Thank you so much for the insight, Marwan, especially for around the ISPs, because we are in academia, so we don't usually get this insight, and that's why we've come to the IRTF and IETF, essentially. So as for the economics of Georgia, yeah, I think a lot of organizational logistics are the reason why a lot of these rural areas are unable to get service. So I think that's really important, and even though, so we highlighted this issue, and the next step is to see if we can fix this issue for rural areas. And as for your other question regarding standardizing this framework for an internet draft or something like that, I agree with you. A lot of this source code is actually handcrafted using basically me and a couple other PhD students and developers, and it takes a lot of manpower. So actually, it would be nice if we can standardize this framework in the RFC so other people could start contributing other ISPs from all over the globe, essentially, and make ISPs more accountable. Thank you.
Yeah, so this is really relevant to some of the work we are doing in the IRTF, so in groups like Gaia and Dynergy. So yeah, I'm looking forward to see how this could be taken up and used for future research.
Thank you.
Rod is next in the queue.
Hi, that was a fantastic talk. Thank you for the important and incredible work. There's quite a bit of heterogeneity across the different geographic areas, the different census blocks. Have you attempted to correlate that to the existence or level of activity of any sort of activist groups or education groups or anything else among the people on the ground who are actually affected by these issues?
So I'll say that of the states that we investigated, a lot of the state governments saw these responses and were quite shocked of the use of the funds. So we did get responses from state governments, but we have not yet looked at a lot of local communities and things like that. I think that's our next step, because like we are a single team at UCSB and we're trying to get everyone involved in this. I think we've gotten a few responses, but thank you for bringing up this issue. I think we should do more for that.
Great. That's going to be even more work. So good luck with it.
Thanks.
Rüdiger.
Rüdiger Volk. I'm not a researcher. I used to be running a large national former monopoly telco internet. I wonder about what the coverage of the program and thus your investigation is. Did the program actually cover only support for commercially organized service providers? I remember IETF presentations from people who were serving, say, the Canadian First Nations somewhere up in the very north of Ontario, and they certainly would be completely outside of the capitalist economy.
Mm-hmm. Okay, so I see your point. So I think actually the CAF program, at least phase 1, dealt with around 35 ISPs, and most of them were very big. As you could see, the major players in the monopolies of the area like accounted for most of the funding. And I'm not sure if many small players actually entered the picture in this case. Is that what you were asking? Or
yeah, well, okay, did the program actually allow a local self-help or self-help initiative to apply for funding? Say in some of the tribal areas. I think some of the tribal areas have this kind of self-help cooperative thing, and it would be an indication of failure of a policy if that would not be if that wasn't supported.
Okay, yeah, I think I understood your question better now. Thank you. As far as allowing a lot of these self-help organizations to apply for funding, I'm not sure if that's the case. I'm not sure if that is the case because we didn't really investigate the policy language too deeply. Actually, we collaborated with a law professor from UC Berkeley, so he was able to give us that insight on it. But I will reach out again to our law professor contact and ask him about this. I think this is an important issue, but I guess we were focused on the analyses, basically. Yeah, thank you.
Hi, thank you again for the wonderful presentation. I really appreciate it.
Thank you.
Question.
I think you have to move closer to the mic.
I'm too short. Okay, hopefully it's better. My question is related to Marvin and Rutger's question, because fundamentally, I think there is a misalignment of the incentive here. ISPs need to invest a lot to serve a relatively smaller number of customers. And so I'm curious about your thought of how to make the incentive aligns. And I can offer two things that from my observation. One is potentially invest in technologies that can serve remote area without a lot of more additional infrastructures like low orbit satellite. The second one is related to Rutger's point. I know in Colorado, for example, there is a lot of local city government-run ISPs that start serving the local community. And that, from incentives perspective, it's more aligned with the self-help kind of thing, and that can make the incentive align. So curious about your thoughts here.
So my thoughts on this are, again, I think maybe I should also give a counter argument to our presentation in that we are not exactly blaming any ISP, any single ISP for this issue. We're essentially just looking at the data and showing our results from it. And we all understand in our conclusion as well for our paper we wrote that this is a policy issue and there needs to be more alignment between policymakers, ISPs, as well as the users. So as for your question on allowing local communities as well, and there's like a misalignment in incentives. We actually did talk to some folks in policy, and they did say the CAF funding, even though it was quite a lot, was not sufficient on a house-by-house basis in order to deploy the amount of like fiber infrastructure and things like that. So it was not really economically like good, essentially, for a lot of ISPs to do this. So we think that this is mainly a policy issue. Maybe in the future, they could have a better like framework for certification and increase the incentives. So ISPs actually have incentives to build fiber and have enough funding in each of these areas. Or maybe instead of looking at big ISPs, you can also look at small ISPs, community run, and seeing if they have a better time at it. So yeah, thank you so much for your question.
Okay, yeah, thanks again for doing this very important work and for coming here to us to present it. So I'd like to congratulate you on your work and the prize that you have won.
Thank you so much, Dirk. Thank you.
Okay, and we are moving on with the second ANRP prize talk. It's the second, and this is Henrik Zech. And Henrik is a PhD student at the Technical University of Munich and is supervised by Jörg Ott. So Henrik is currently working on improving the understanding of LEO satellite networks through measurements and analysis. And he's also working on multipath transport for mobility scenarios. And now we're looking forward to his talk on a multifaceted look at Starlink performance.
Yeah, thanks a lot for the introduction. So I'm really honored to be able to speak here today and present our paper on Starlink's global performance from me and my co-authors. This was a collaboration between the Technical University of Munich, where I'm employed, and the University of Edinburgh. Before we start off, I would like to give a short preface. This paper was published at the ACM Web Conference last year. Most of the data is from late 2023. As you will soon see, the Starlink network has evolved significantly in the meantime, and I will try to highlight where things have changed and also likely performance has changed. I really hope that my voice will make this talk and that you all can understand me well. Let's kick this off with quickly looking at the history of satellite internet access. So internet access through geostationary satellites has been available for many years. The upside of that is that the geostationary satellite is in a fixed position relative to the Earth's surface, and that it covers a huge area of the Earth. The major downside, however, is that due to the large distance, the round-trip time is at least 600 milliseconds. In recent years, companies such as O3b mPOWER, Starlink, OneWeb, and Amazon's project Kuiper have explored satellite constellations in lower Earth orbit, in MEO, medium, and LEO low Earth orbit. The advantage there is that due to the shorter distance, latencies are lower. However, the main challenge there is that the satellites are actually moving out of view with respect to users, and that you need a lot more satellites to provide coverage everywhere at any time. Starlink is really the front runner here. Today, they have already more than 7,000 operational satellites, and they plan to deploy more than 40,000 in the coming decade. To become a customer of Starlink, you have to live in one of the unlocked countries. Then you can buy user equipment from them, and they provide you with low latency, high bandwidth connectivity. To give ballpark numbers, maybe round trip times of as low as 25 milliseconds, downlink throughput 250 Mbps are common. And with that, Starlink is actually emerging as a global ISP because it provides satellite services, internet services around the world. The deployed satellites are deployed in different orbits. A satellite orbit is defined by its inclination, which is the angle at which it meets the equator. Most of the satellites are in the 43 and 53 degree angles. The main point I want to make in this presentation is that actually Starlink's network performance is globally inconsistent. There are multiple reasons for that, but one of them is due to the way satellites are deployed and the service is available on Earth. Projecting the satellite's orbit on a flat map of the Earth shows which regions on Earth are covered by which orbits. The 43 and 53 degree shells cover the most populated areas on Earth. However, the northern and more southern latitudes are only covered by the less densely populated 70 and 97.6 degree shells. The second thing this map shows is the deployment of Starlink's ground infrastructure, which consists of ground stations and points of presence. I will go into their function next, but I quickly want to highlight that the density is really high in North America and parts of Europe, but much less dense in many other parts of the world, like Africa, South America. Starlink works by having the user, through the user terminal, connect to a satellite overhead, which relays the data to a Starlink-supported, Starlink-operated ground station. We coin this part the bent pipe because it, well, resembles a bent pipe. The satellite is simply forwarding data in both directions. Since the satellites move, the user terminal frequently has to reconnect to a different satellite, but also the connection between satellite and ground stations changes frequently due to the movement. What, however, stays fixed is the selected point of presence for a certain user. This provides internet services with a stable IP address to route their packets to, which again allows a stable connection, even though internally there's a lot of churn, a lot of changing connectivity. What, however, if there's no ground station inside? For this case, Starlink satellites support inter-satellite laser links. What these do is they allow satellites to forward data between them, effectively realizing an extended band pipe. Data from the user terminal goes up to a satellite, is forwarded to multiple satellites before coming back down to Earth again. From the outside perspective, this is not visible and also not visible to us directly because those don't show up in, for example, trace route measurements. And within that availability of ground infrastructure really lies the key point, the second key point why the Starlink's global performance is inconsistent. You could argue that Starlink is not actually a space network operator, but more akin to a cellular network operator. The satellites serve as ground stations do in your 5G network, effectively. To support these claims, we analyzed different data sets. One is the large MLab TCP speed test data set. For those of you who are not familiar with that, if you type into Google search speed test, you will be presented with a widget. If you run the speed test, you can later query your test results through the Google BigQuery interface. What we did, we filtered for the Starlink AS number and were presented with almost 20 million data points from 34 countries back in 2023. So by now there should be a lot more data available. That's great, but we were also trying to get a deeper look through targeted ping and traceroute measurements. And fortunately, again, even back in 2023, there were already close to 100 probes available on RIPE Atlas. From those, we ran over a month measurements toward different data centers on different cloud operators. First, I would like to look at the Starlink latency performance, and we set this into context by comparing Starlink on the left-hand side with mobile network operators on the right-hand side. The blue-colored countries provide the best latency, and already on the first look you can see that in most cases cellular networks provided better latency performance. Exceptions, therefore, are North America, parts of Europe, for example. However, there were also regions where Starlink performed really poorly, which is Kenya and Mozambique in Africa. But there were also in Africa the case of Nigeria, where Starlink worked equally well as Starlink. We will soon look into why. First, however, I want to make the point and draw the comparison again between the latency performance and the availability of ground infrastructure. In the CDF, you can see different selected cities. And for the ones that perform very well, Dublin, Lagos, Manila in the Philippines, we observed that ground stations and points of presence were really close. There are also outliers, like, for example, Mexico City, where we observed that they had to use points of presence in Brazil, which obviously caused a long path on the ground when you try to access services in Mexico. We split the performance by region. On the lower left side, you will see the US, where the latest performance is really homogeneous, and Starlink worked really well. Again, a very dense ground infrastructure there. In Europe, the performance is still very good, but it's more dispersed. In the UK, for example, they have 2 points of presence close, while in the case of Italy, where Starlink didn't work that well, we again observed suboptimal routing, where users were assigned to points of presence in Spain, which again caused very long terrestrial routes. On the lower right, you see selected countries from South America, and overall the performance, especially compared to the other regions, was much worse. Here we saw that they had to take a really long terrestrial path to get to their services, or even to travel between ground stations and point of presence. Now I want to look into 2 interesting cases that we found. So we observed, or we looked at users, Starlink users in the Philippines that connected to a server in the Philippines and one in Japan. And what we observed was that the latency was much lower when the Philippine users connected to a server in Japan. Looking at the data, we found that these users had to use a point of presence in Japan. So a packet from them traversed from the dish to the satellite to the ground station through the subsea cable to Japan, then originated from the POP, had to go to the subsea cable again to reach the server, their destination server in the Philippines. After May 2023, Starlink established a point of presence in the Philippines, and we accordingly observed that the round trip time decreased significantly and was more aligned with our expectations. Another interesting case concerns inter-satellite links. So there was a RIPE Atlas probe available on the Reunion Islands. And when running traceroutes through them, we saw that it was assigned a point of presence in Frankfurt, Germany. Since the ground station shows up in those traceroute measurements, we knew that the latency was less than 5 milliseconds, which means that the ground station must also be relatively close to Germany. Since the distance between dish and point of presence was with 9,000 kilometers larger than what a single satellite could cover, we inferred that inter-satellite links must have been at use. We compared the latency of the Starlink connection from Reunion Island to Germany to the fiber connection connecting Reunion Island and Germany, and found that the latency was significantly improved if inter-satellite links were used by roughly 60 milliseconds. However, what I want to highlight here again, often users want to access services that are closer to them geographically. And in that case, the packet would have to travel through the terrestrial path from Germany to the destination server and had to take the full way back. So while this is a really cool result that inter-satellite links can actually improve latency, in practice, this might not result in actual performance improvements for users. I would like to compare what changed since late 2023. So I ran our plotting scripts again with current data. And what we see is that the density of ground infrastructure increased even further in the US and Europe, but there were also a lot of new regions where at least some Starlink infrastructure is present. One of them is the Middle East, where the first ground station was established. Also in parts of Asia, there has been more service, and in South America, we also see especially more points of presence. From our finding, this will likely contribute to performance today. And finally, in this section, I want to talk about the band pipe latency. So what we mean by that is how long it does take a packet to travel from the dish through the satellites back to the ground station. When we did our measurements with RIPE Atlas data, we found that it was roughly in the bracket of 35 to 50 milliseconds globally, but we found outliers with more than 100 milliseconds latency. In 2024, Starlink published a document outlining that they want to improve Starlink's latency, and also gave some hints at what they wanted to do. Some of the measures were improving the radio front haul, others increasing the ground infrastructure, but also adjusting queues throughout their system, queue sizes, but also queuing algorithms. They didn't go into more detail, unfortunately. Just last week, they published another update where they plotted the data from users in the United States that shows a huge drop in latency mid-2024, going from around 45 milliseconds to 25. After analyzing the global performance, we also looked targeted with using Starlink dishes that we controlled different real-time applications. We selected Zoom conferencing and Amazon Luna Cloud Gaming as demanding real-time applications where we could also actually measure key metrics that affect user performance. Our takeaway from that was that Starlink, similar to the latency results, is competitive with 5G deployments. Competitive here means it not necessarily works better, but it's on a similar level. However, compared to the terrestrial connection we use on our university network, which should really serve as a good baseline, the latencies on Starlink are higher, and we observed more packet loss. However, we also observed periodic degradations, which I want to look at next. So here's a part of the Zoom test that we did. On the left-hand side, terrestrial connection, right-hand side, Starlink. And what we see is that Starlink had a relative constant bitrate usage of 1 megabit per second. But on Starlink, we observed regular sudden shifts in latency. And on top of that, Starlink Zoom decided to activate a forward error correction module, likely in response to the higher random packet loss rate on Starlink. As we see in our metrics, this, however, resulted in a good user experience. Now I would like to look into our cloud gaming results, and first looking at the table and the key metrics, frames per second and bitrate, we really see that both 5G and Starlink were able to deliver a great performance. Both stuck close to the 59 frames per second, and both of them also delivered a higher bitrate. We saw that sometimes they decided to switch to a lower resolution temporarily, and there were also freezes present. But overall, the user experience was great. In the game delay, which is a custom metric we measured, which is the time between the user pressing a key and him seeing the response from the game on screen, there we see the impact of the higher round trip time. Starlink and cellular had about 30 to 40 millisecond higher game delay. Again, we plotted a part of the transmission over 5G and Starlink, and again there we see at certain points dips in the frames per second. I would like to look into, we tried to find out what caused these, and already previous research hinted at Starlink running a global network scheduler that would reassign satellites to the dishes on a 15-second schedule. While measuring throughput, we also observed that the throughput shifted or seemed to shift to a different level at certain points, with a dip in throughput while that shift happened. We also conducted fine-grained latency measurements. There we actually used both dishes that we had available from our colleagues in Edinburgh and in Munich, Germany. And what we also saw with latency is that it shifts at 15-second points, and therefore was very unstable when you look at it on a scale of a minute or two. Our analysis showed that these reconfigurations are present at both locations, but also that the time at which they happen is actually globally synchronized. So they happen at every minute at the seconds 12, 27, 42, 50, 57. And within those, as I've said, latency, the value is stable, but it fluctuates at these borders. Looking more at that, we at first came up with a high hypothesis that the dish would actually change satellites at this 15-second point, and this would result in the change in the performance. Andrew, our co-author in Edinburgh, was in the fortunate position to have access to the 70 and 97.6 degree orbits. And what he did, he built up a test setup with metal shielding that prevented the dish from connecting to the 53-degree orbit. Using publicly available movement data from the satellites, we were able to calculate how many satellites would be in the field of view of this dish at any point in time. We again ran, or he again ran the round-trip time measurements, and we found many instances where we saw the shift in latency at this 15-second marks, but the dish was not able to connect to a different satellite because there was only a single one in view. And the second thing we observed is that the start of the connectivity, so changing from no satellite in view to candidate satellites being available, the start of that connectivity was equally distributed relative to the previous reconfiguration. However, the end always coincided with that 15-second mark. What we took away from, or take away from that, is that Starlink is not necessarily performing handovers at those 15-second points, but there's definitely some network level reconfiguration or load balancing going on. That can be a satellite switch, that can be that the satellite switch to a different ground station, that could be that the user is assigned to a different beam, to a different frequency, that the encoding changes. Starlink is not open about what exactly happens, but we can definitely make educated guesses. And with that, I would like to wrap up my presentation. In the global performance section and the real-time web application section, we saw that Starlink is competitive with 5G deployments. The performance definitely varies globally, and this is due to the way satellites are deployed. So due to the availability of ground infrastructure and the quality of the service from the point of presence. We found suboptimal routing decisions during our study that can involve ISLs, but can also be due to surprising assignment of points of presence. We found that the uplink latencies are variable, and that applications can find ways to deal with that. And we found that the reconfigurations that happen every 15 seconds are globally synchronized, and that they result in subtle latency and bandwidth shifts. Thanks a lot.
Okay, we have time for questions. T1.
Hi, thank you for the presentation. We also did some study looking at Netflix data, and we also see a similar conclusion that there's a big global variation. And one question I have for you is that when we saw the variation, we also compare with the local alternatives. And in Africa, in some of the countries, even though Starlink does perform much worse compared to their performance in other countries, they are better than the local alternatives from Netflix perspective. So I'm curious about your observation in your data set, whether you compare with the local alternative and whether you also see similar things.
Yeah, so especially in Nigeria, actually, we found that even in our data analysis back then, Starlink performed similar or sometimes even better than the local 5G deployment. I think with Starlink, the performance also in these regions can be great. We just need the availability of this ground infrastructure. Obviously, since the Starlink signals go back to ground as soon as possible, the available internet infrastructure there still plays a big role. But if you have service deployed locally, that effect might be reduced.
One question. So I assume that the reason for the point of presence selection is like legal requirements that you have to exit the network in the same country where you currently are. Is that correct? Or... Okay. Do you know anything about it?
I don't know about illegal requirement. It's definitely possible. What Starlink does is that it assigns IP addresses where they publish a list that they map IP prefixes to countries. So you can have a certain level of granularity of geolocating the users. But we saw many cases where actually user connections terminated in a different county than what Starlink reported where they were. So again, you need to rely on Starlink that they actually do the IP assignment correctly, so that our assignment of user to countries is actually correct.
Right. Okay. Thank you.
Hello, Robert from Hasso-Plattner Institute. Thank you very much for your work. It's really a lot of amount of work. I'd be interested in how did you or what metrics did you use to measure your RTT latencies, especially on RIPE Atlas?
So on MLab, we use the minimum RTT feature that's available there. They subdivided into second metrics, and then we selected the lowest one. On RIPE Atlas, as far as I know, we ran ping measurements in parallel to traceroute and used those. So ICMP.
Thank you.
Hi, Corinne Kat, Article 19. Thanks again for, I mean, as has already been mentioned, the incredible technical work that has gone into this. I had some questions about maybe some of the underlying social assumptions that you are making, which I want to question from the perspective of someone who also works on this issue or has a team who works on this issue, but within the international telecommunications spectrum debates, which is like, we need to be very careful about equivocating Starlink to ISPs. Obviously, like the majority of data traffic will still go through deep sea cables. And if we start to talk about Starlink as if it is an ISP like any other, we make a bunch of political and social assumptions that aren't true. Starlink is very different from local ISPs. It's a very different connectivity provider than maybe some community networks are, and one that, especially in the current moment, is a geopolitically unstable actor. And obviously, that's not the research that this is, but I do think, especially for the kind of super important technical work that you do, where you do show like this really uneven distribution across the world in ways that are very important, we also need to take that next step and be willing to say, like, this is an actor in and of its own that does something that we need to all grapple with, but let's try not to sort of put them at the same position, because that makes it seem like they are somehow a substitute for local ISPs. And I don't think that's the world to which we want to be moving, because we've seen what that means in places like Ukraine, where they do become a critical connectivity provider until one morning Musk wakes up and he's like, I no longer feel like footing the bill for this, so y'all are on your own. And so this is maybe more a comment of a question, but I was wondering, sort of given that sort of broader context, why you, in the very, very initial framing of the presentation, made the decision to think of Starlink as an ISP, as opposed to setting it apart as somewhat of a league of its own in LEO connectivity.
Maybe I'm not aware of everything that characterizes an ISP. I made that decision since I also made the comparison to a mobile network operator that has this infrastructure, base stations, for example, and provides wireless internet access to its users. And in that regard, I classified it as an ISP.
No, thanks for that explanation. I think the question here also is that there is a broader one, and Harika's talk in that sense ties really nicely into yours, which is we are very quick to say that any connectivity is good connectivity, right? And that's just not the case, and that's also what your presentation shows. So I guess what I'm arguing for is just like a very careful, also locally informed perspective as to, just because mobile operators is what is being offered doesn't mean that that is the best that is on offer. And the same goes for Starlink. I do think that we should be aiming for really good connectivity for people, not just whatever this company or other companies have on offer.
Yeah, I definitely agree with that point. It would be great to have some competition in the LEO space. I guess there are many economic reasons why that is difficult, but I don't think a monopoly in that space is good for users.
Hi, Debopam. So you mentioned that the traffic at times was exiting via the Germany endpoint, right? So I believe that there could be similar cases where places like Germany could become hotspots, becoming a sink for traffic from many parts of the world, right? So it's kind of important that we measure whether also the inter-satellite links that are leading to Germany are getting congested. And do you have any follow-up experiments in mind that sheds light on whether it's the non-terrestrial part of the network or the terrestrial part of the network that is to blame for any congestion or performance differences?
Sorry, I'm not sure if I 100% got your question. So the question is about if you inter-satellite links uses bad performance due to the inter-satellite path or the path on Earth?
Yes.
I would say we find, I guess it depends on who you're communicating with. So what we found is that in this case that there were times where it was great that the large distance from Africa to Europe could be covered faster with ISLs. If the server there is your destination server, it can quickly go back over ISL spec, then it would be an advantage. But we also and I guess this relates to follow-up research where we might have been looking at the performance of CDNs, where it's really crucial which CDN service users are assigned to. It should not be done based on the physical location of the user, but where actually the packets get down to Earth.
Yeah.
So I would think really that determines the performance in these cases.
Okay, thank you.
Rod.
I have two questions. One that you might want to defer to somebody else, but the other one's for you. Let me start with the second one first. When you were talking about measuring the latencies back on about page 10 of your slides, I didn't fully understand where the endpoint of the ping is, and even a bigger question is how do you actually measure this fairly given the heterogeneity and the distribution of where people are really connecting to, where the servers and services are that they're connecting to?
So this is connected, the latency from the user to the MLab server that's assigned to them. We didn't have any influence on that, obviously, because the tests were already done. But as far as I know, MLab does that by geolocating the user based on its IP address and then selecting hopefully close server to them.
Okay. And if there's time, then looks like we got a minute or so. Back on the page you were on right when I started this, page 20, the satellite orbits. Just out of curiosity, this is probably not your bailiwick, but the wrong direction.
Sorry, which one do you mean?
Page 20, where you had the tracks of the 53 and then 90 or high latitude.
This one.
Satellites. Yeah, there. Just out of curiosity, right in the middle, just below, just offshore from Africa, all 4 orbits come together, but over in the Pacific, they don't come together. Why is the high latitude one not match up? What am I not understanding about orbits? Is that some secondary effect due to either the sun or the moon?
So what we have plotted here is one orbit, but the satellites are deployed in shells. So that means that they are equally spaced apart around the Earth, and then take the trajectory around it. But in this case,
I would expect if you just took a set of orbits and
if anyone's here who has an idea, please go ahead. Sorry, but otherwise I can't.
If it's outside your expertise, that's fine. I was just curious if you knew.
Yeah, no, sure.
It's not relevant to the content of your talk. Fantastic talk, by the way. ANRP is really hitting it out of the park today. Both talks have been great so far.
Jeff Houston, let me be really quick. There are a number of orbital planes where there are trains of satellite equally distributed across the orbital plane. And so those planes are 53, 70, and so on, right? Then laterally, if you think about it, there's another one inclined and another one and another one. So he's plotting one path. There's another path that you could think about on a map as being 1,000 kilometers to the east. Same path, but eastward. Another one, another 1,000. So there's actually a grid of paths at each orbital plane. So that's not every satellite is on the red. There's a whole bunch of reds spaced around the world. Thanks. If that helps. It's hard to describe in English. It's easier with a map.
Thanks, Jeff. I need to think about it a little more.
Okay. I'd like to wrap this up now. Thanks again, Hendrik, and congratulations on your prize. Okay, so now I'd like to invite Herman de Meer to the stage. So we're really glad to have Herman de Meer with us today. So he's a professor for computer science at the University of Passau in Germany, and one of the pioneers in sustainable research in the context of renewable energies and computing and communication. He's also a participant of the last year's Darkstuhl seminar on greening the internet that then later led to the foundation of the proposed Sustain group. And now we are curious what he has to talk about today.
Okay, thank you very much, Dick. Yeah, topic is a bit different to the previous one, however, somehow related. I want to talk about the interdependency between power and ICT system, and this is I think not so easy task to talk about all of that. I'm giving my best. Hopefully, I can get the message across. We did some projects in the past. I want to mention them. I mean, they're a bit outdated. For the last 15 years, starting in 2010. But I think it's quite instructive to look at what came out of those projects and what we learned from them in the long run. So we had this project Fit for Green. As Fit for Green, the goal was to optimize electricity usage in data centers, as I mean, many projects actually do. And so we started off by investigating various data centers. So the Hewlett-Packard Cloud, Jülich Supercomputing Data Center in Germany, and a small data center. We tried to investigate what we could do about these data centers to save energy. And we felt we were quite successful because we achieved saving rates about 20 to 40%, which was tremendous because servers typically were highly underutilized with a utilization of 20, 30% or something like that. And we tried to do everything to consolidate, virtualization to be applied, shutting off servers, and shifting loads, whatever we could do, right? And we were quite happy about that result. And when we were done with the project, I got a call from this CEO from the smaller company and said, "Are you crazy, guys? What have you done? Our energy bill went through the roof." I said, "What? We saved you at least 20% of energy." So yeah, but terribly, you know, the local energy provider, they charge us so much and so forth. I thought, oh, they must be stupid. But then I realized maybe I'm stupid, right? I didn't get the whole thing, the big picture, what's going on. So I sat back and started thinking, and what I realized is we messed up with the system. We messed up with the power system because in the power system, there is to be balanced supply and demand at all times. And great effort has been taken for that, meaning that you have to look ahead of time, make some predictions, make some plans such that supply and demand and meet. What we did, we messed up with that, right? Meaning that the utility, the local energy provider, had to charge extra costs because of our messing up, meaning that all these profiles, the load profiles that were negotiated, failed, right? And as of a result of that, to make ends meet, they had to use reserves and to make up for all of that, and they are much more costly. So meaning that while we saved, let's say 20%, the extra costs were about 500%. So there was not a really good trade-off. Okay, then we moved on. We moved on to the next project called All for Green, where we did something that's also quite popular right now, where we applied demand response schemes, in particular in order to save carbon emission, right? That was the goal there. And again, we were quite successful. There was some good outcome, for example, where we designed something I think that could be quite interesting right now, the green SDA and green SLA concepts. However, did we repeat our mistakes? I said, yes, we did, because we did exactly the same thing. We messed up with the power system that we confused all plans that were there because we shifted loads without negotiating with the energy providers. So we messed up with the load profile again for very good reasons, for very good intentions, but we repeated the same issue. Then we moved on to the third project called DC for Cities, which is again sometimes back. Nowadays, there are projects all across Europe about energy communities. At that time, it wasn't called energy communities, but we tried to manage the energy of the city of Barcelona. So it was actually a very large energy community. Also with a goal to optimize the usage of renewable energies and doing things like that. Good results, however. Did we repeat our mistakes? Yes, we did, stubbornly. And same thing happened again, that we messed up with the profile of the energy suppliers to the city of Barcelona. Is this a question right now? No, sorry. So yeah, and so I think we made all these mistakes, and I'm pretty sure all these mistakes are still repeated nowadays. So that's the starting point where I thought, well, I need to understand systems better, and looked into this and started to lecturing on power systems as a computer scientist and as a networking person to understand things much better. Now, what is the power system all about? Well, the power system consisted in the past of large-scale generation capacities, power plants, and transmission and distribution networks. Top-down, highly centralized. Germany with about 300 bulk generators, and the power was flowing from the center to the edges. So different levels of voltages that connects them, and then there's the end users. With the renewable energy transition, lots of things have changed right now in the front of our faces, and these changes are sometimes subtle, and sometimes we're not so aware of what has happened there. One thing is, of course, which is quite insightful, and people know about that, is that the sources are volatile, meaning What does it mean? Well, there's volatility, and we need to make up for this volatility, meaning if we plan, make predictions ahead of time in order to make ends meet, supply and demand. If there's volatility, it means that we have to have more reserves in place in order to compensate for that volatility. So far, so good. So things getting a bit complicated, maybe getting a bit more expensive on the one hand side, but they're getting cheaper and more carbon, less emission based on the other side. So there's an interesting trade-off. Now we came about with messing up with the load profile, meaning that we introduced additional, in the previously mentioned project, additional insecurities in terms of making predictions, which again made things more complex and costly. But that's not all. If you look at the power system, then what happened is there's a really a change of structure. And this change of structure led to things like reversal of power flow. All of a sudden, you have power flows from the edges towards the center of the power grid. What does it mean? Well, if you look in details, it means all of a sudden, in some cases, protection systems don't work anymore because they're built with flow directionality in mind. Meaning that we have all of a sudden a degradation of dependability measures on various in various contexts. So with regard to protection, it means safety. So we have a reduced safety all of a sudden, which of course is a detrimental feature. The other things, since we have, instead of 300 generators all over the country, now there are millions of generators dispersed around. It's a distributed system, and power is fed into the grid in the distribution section where capacity is low, which led to substantial, really substantial congestion in the power grid nowadays. This is one of the most pressing needs or challenges, congestion in the power grid, which means reliability of supply is endangered. So the transition of the energy system led to a lot of changes, subtle changes that led to a degradation of various dependability measures. Another change that has happened, also in front of our eyes, sometimes unnoticed, sometimes noticed, is with the decentralization and the decommissioning of the bulk power plants. We not only decommissioned the bulk power plants and the electricity supply by them, but also the system services. They were also decommissioned without sometimes noticing really it. System services are really essential for the power system to work properly. System services are used on manifold, but the most prominent of them are supporting frequency and voltage levels. Now, if you ask, is this important? How important is it? Then please think back, a couple of weeks back, there was an outage, actually not an outage, there was a blackout all over Spain and Portugal. And there's evidence that this outage is due to the non-availability of crucial system services. Now, the analysis doesn't show why they weren't available, but clearly they were not available. And of course, if you decommission sources of system services and don't think carefully about how to rebuild the system services, you might end up in a situation that we have faced a couple of weeks back. So this is very serious. So again, dependability of the power system has decreased. Not that this is unavoidable, but in practice, apparently the measures are insufficient. And the NSOE, as the organization that is around the transmission grid operators in Europe, they have warned, literally warned some years ago, that we are facing serious problems if you're not careful enough with system services, right? They have been reduced significantly, and no real measures have been taken in order to replace them based on dispersed, distributed renewable energy sources. Things could be done, but they are not really rolled out in practice as far as I know. So there's many of these challenges, many subtle challenges that are not so obvious. So we need to take all of them into account in order to come back to a reliable power system. So important is really the takeaway at this stage is dependability has decreased substantially. And there's a measure of the change of dependability. We call this resilience. Actually, this is wrong here. It should be the unresilience is proportional to the gradient of the change of dependability measures. This is something really to be investigated. I think it's also very important for this community to take into account and work against this and improve this situation. So we need protocols and we need standards in order to compensate this, this change that's happening in front of our eyes. So to remind you, we need to balance supply and demand at all times on a global scale. Global scale means whatever is to be organized as one grid segment, for example. Typically this is countrywide. Which means we need to have forecasting in place and control, and this forecasting have to be precise. If the forecasting is imprecise, we have to make up for this for providing reserves. Backup reserves are very costly, and I told you with the reference to our projects that the corrective measures are much more expensive, much more carbon intense than anything else. So we have to be careful and think about this particular trade-off. So energy efficiency and energy efficiency is not the same. One has to be very, very careful in this respect. So do not mess up with the power system. It's very important. Whatever we do locally, we have to adhere standard profiles. We have to negotiate profiles with the energy providers, with the grid operators, and we can do everything we want as long as we do not touch these profiles. I think that's a very, very important message to take along. So this is for sustainability. It hinges on these interfaces or profiling that needs to be maintained in negotiation with the grid operators, in negotiation with the energy providers. Yeah, a few more details about these interdependencies. Of course, it's not only us, but the NSOE has considered seriously interdependencies of ICT and the power system, particularly from their perspective on the transmission grid, but also applies to the distribution grids that are out there. So we introduce, now I mentioned all these issues, the challenges, the degradation of dependability measures, but we can do something about this. And one obvious thing is, that's why we're here, is to build ICT systems that mitigate these degradations in dependability measures to make the system again reliable, safe, and what have you, right? Meaning that there's this ICT to be introduced. At the same time, we need to combine proactive measures and reactive measures, and they need to match. So we need to think in both ways. Proactive measures planning, making ends meet, being reactive if things do not match perfectly. There's more cost to the second part than to the first part. This is extremely important. And if we don't do this properly, we see degradations in performance. So ICT comes into the picture and helps. That's great. But we all know there's no perfect ICT, which brings us to another challenge here in this context, that whatever we do, we need to account for degradations in performance and reliability of ICT components as well. There's another complexity we really need to think hard of, right? We have a distributed system, and it's notoriously difficult in distributed systems to be fault tolerant. I mean, this is one of the biggest challenges we can think of. Now we're having the combination of two complex systems, the power system and maybe communication system and ICT system like the internet, and bring them together. So it's also well known that system of systems could lead to other challenges and issues, that there could be cascading effects. You bring systems together, you're getting a new quality, and looking at complex system theory, you can prove that there are these tipping points you could reach. So now coming back to more practical things in terms of the NSOE has investigated the interdependencies between power and ICT systems, where they distinguish between high-level services. They are designed in order to maintain the normal mode of operation of the power grid, in particular the transmission grid, but the same applies to the distribution grids. And then there are remedial actions that are in place in order to take corrective or preventive agents against contingency that might be around. Now, what if ICT doesn't work perfectly? There's degraded mode or even failure mode. What effect does this have? That's something also studied by the N2E. Now you can see this coupling of power and ITT systems. Of course, I mean, ICT needs power to work properly. If the power quality is degrading, ICT might also be affected, right? If you have voltage variations, high voltage, meaning ICT components might be disconnected because they cannot sustain over voltages. And where the over voltages come from? Well, they come from congested grid, for example. If too much feed in is to the grid, then voltage increases and might damage devices. In this respect, oversupply is worse than undersupply. Then many devices can sustain lower voltage but cannot sustain higher voltages. So it's quite interesting and challenging to look at that. On the other hand, the power system strongly depends on properly functioning ICT, right? That's rather obvious. Now, we need to take into account various factors. I mean, there's data communication transfer, there's computations, there's data management in place. We all know that. And of course, we have different measures about the quality of the ICT side, so data availability, latencies, and correctness of data. Now, these different quality levels might affect the services that we're looking for in order to support the power system. So it's good to distinguish various service states. Everything is fine, the normal state. Something might be degraded, so it's a limited availability, limit performance state of power supporting services, and the service might fail completely. So this is a very coarse grain classification of various states. Power supporting ICT-based services could be in. The N2E, by the way, just distinguish between normal and failed states, of even coarser grain classification. And this is very service specific. That needs to be taken into account. Some services are much more tolerant than other services. So it's very good to have a service oriented view on that, and then see what are the interdependencies of the services and the power grid. So the N2E also classified the power systems to be in various states. Correspondingly, everything is fine, the normal state. Then there's the alert state, meaning that there are contingencies, but there's not yet any security breaches. Then there's the emergency state, where serious security breaches have arisen. And then there's the blackout state, where, of course, we have the worst case situation. Now, N2E took some care about finding out about interdependencies, about various ICT-supported states with regard to the global power system states. For example, the state estimation is a very, very important core functionality, core service, and this has serious impacts onto the power system. So by definition, if the state estimation service fails, then automatically the power system is to be seen as being an emergency state, and some drastic action need to be taken. On the other hand, there's also interdependency between the services that are used, ICT-based services. For example, I mentioned before that protection might not work sufficiently well anymore, and at least not to 100%, but to a limited degree. Now we can fix that by using ICT. If you use that fixing ICT, but ICT doesn't work properly, because if you talk about protection, things have to be corrected within milliseconds, sometimes very, very fast. So latencies matter a lot, meaning that if state estimation doesn't work properly, either degraded mode or failed, it might have serious impacts onto the performance of adaptive protection, right? That's also some interdependencies. That's important. And then adaptive protection, again, has impact on the power grid, right? If protection doesn't work, I mean, then definitely we are in danger that something serious might happen. So security breaches might be in place already. So there's a quite cumbersome, complex interrelationship. And of course, this figure is completely incomplete, right? It's just a sketch of a few transitions that are possible and are likely. In practice, it's much more complex. Most of them are left out, and of course, there are dozens of this ICT-based smart grid services, and the complex interaction between them and the complex interaction with the power grid. And on top of that, there is an interaction from the power grid to the ICT service, which are also left out in this simplified figure. So state-based approaches as such, of course, getting cumbersome the more complex the system becomes. But I think the principle should be clear. So there's a strong increasing interaction, interdependency between power and ICT systems that we need to study very carefully. And I think that's something also of interest to IETF or IRTF to look at. There's one difference here with regard to state transitions that affect each other. There's a direct state transition specified by the NSOE that this is by standards to be defined, and there's also conditional state transition that depends on the context, on the environment, what the conditions are in the environment such that a conditional state transition could occur. So that's the difference that's also worth to be mentioned. Now this, as I said, originally comes from the transmission grid context. It needs to be translated to the distribution grid context. That's of more interest to us actually, which is out of the scope of the NSOE. Yeah, so we have a degraded mode. We have not only normal and failed state, but something in between, and this needs to be taken into account. I mean, measurements can be incomplete, data could be distorted, what have you. We all know about that and need to investigate this very carefully, which could lead to some sort of distortions that need to be taken into account. There's also a paper, I don't have really time and room to look into this, about cascading failures, the system of system views. So some of you might be interested to look into that. This is a different abstraction level. I mean, before I showed you the slide on the state interdependencies, where I could do some state-based analysis. The bigger picture is about system of systems views using complex system theory, where you can investigate these cascading failures. So there's a paper on that, which you're welcome to have a look at if you're interested in that. It's a different perspective on the same thing, essentially, different levels of abstractions. So behind all of that is two things. You need to comply with the restrictions of the power grid. That's one thing. And this is new. As I said, there's new congestion, and it's one of the most pressing needs of congestion in the power grid. This afternoon, I give another talk where I explore this a bit in more detail. But there have been, in Germany in 2024, there have been curtailments or redispatch, as it's also called, in the order of many gigawatt hours. So if you want to see what this means, is that available energy is curtailed, it's not being fed into the grid, although it might be used at that very moment in time, very much so, because there could even be undersupply. But at that very region of the power grid, there's congestion there. So there's curtailment. This energy is not to be used, and the amount that was curtailed that way in 2024 in Germany alone amounts for about 13% of the electricity needs of Google worldwide. So you can imagine what this really means. It's a tremendous loss of energy, and that's just for the German situation. Other countries, of course, come on top of that. That's also something to keep in mind if you think about energy efficiency, right? We make a lot of effort saving here and there some kilowatt hours or maybe megawatt hours. On the same time, we're wasting thousands of gigawatt hours, right? Which is tremendous. So that's also interesting to take into account, seeing the big picture where we can really do something good and save energy, right? Using that energy would actually, in a way, be for free, right? It's wasted, completely wasted. So that's also a message to take away with regard to what energy efficiency really means. You have to have the system view in mind. Very important in the context of the power system for all these services I've mentioned, ancillary services, congestion control services, they all hinge on flexibilities. So you need to have flexibilities in place. Flexibilities are been providing the reactive measure to react towards inequalities with regard to demand and supply and to local congestion in the power grid. You need flexibilities to make up for that. One drastic flexibility is, of course, curtailment, where you're shutting off generators, which is very drastic. There could be more efficient measures to that, but this is the current practice, right? That's something we need to think of, but it's really worth to look into flexibilities. What are flexibilities? They're highly valuable, but they're also costly. They're also very carbon intensive, meaning that, again, coming back to our stupid examples, well, our stupidity, where this project, where we saved energy, but had to pay much more by calling on flexibility resources by the energy providers. And right now, there is interesting project with energy communities, where energy communities try to optimize their self-sufficiency. They're shifting energy back and forth among them, so the parties within the energy communities. However, they do that at the cost of their energy providers. And the energy providers have become really, really mad. And actually, they're starting to refuse serving customers who are part of energy communities, because they create much higher costs and CO2 emissions in the system, because they need to make up for all this shifting around and optimization locally within the system, right? They need to procure flexibility resources such that they can make up for these actions. That's why it's worthwhile to look into flexibility, flexibility resources and flexibility potential and flexibility requirements. This has to do a lot with, I mean, okay, some similarities with regard to what we had about 25, 30 years ago when we looked into quality of service and packet switch networks, where we had similar questions. There's a certain resource availability, certain quality of service demand. Does it match, right? So you need to have to come up with mechanisms for that, like weighted fair queuing, what had you. Also some mathematical model like network calculus, for example, where you can do some calculations about matching the availability of resources with regard to the demand in the sense of quality of service. Now we're seeing something very similar in the concept of the power grid. There's flexibility requirements. Can we meet these requirements? Maybe under some stochastic uncertainties with what probability? So yeah, flexibility requirements, where do they come from? Remember, we are still looking at these services, and providing ancillary services goes along this scheme that's been indicated symbolically here on the top of the slide. So there's flexibility requirements because we have many reasons for that. Volatility of supply and messing up with the load curves, as we did, for example, which all adds to flexibility requirements. Of course, if you look at wind energy profile, it never matches load demand. So you have to make up for that. You have to have flexibility requirements, flexibility potentials in place to make up. What are the requirements? Formally speaking, requirements are deviations from planned or expected values, right? That relates to or translates to flexibility requirements. Flexibility potential, on the other hand, is that are uncontrolled. I should add the uncontrollable features. Flexible potential, on the other hand, are controlled deviations from a plan. A good example would be a battery. A battery that's half full, you can control it. You can deplete energy from the battery, or you can store energy in the battery. So you can control. So you have flexibility resources, the battery, and it has flexibility potential of being charged or discharged. If it's full, it can only be discharged. So it has then certain flexibility potential depending on the state it is in, and it's always relying on flexibility resources. And that's what's happening for reserves in the power grid. These resources are procured with regard to their flexibility potential to make up for flexibility requirements due to unforeseen deviations from a plan or from stupid researcher who mess up with the system. And built on these flexibility requirements, you can see that then we can provide flexibility resources. We can build flexibility services, right? Ancillary services, redispatch in the context of the power grid. So that's really, really, really important and the basis for a lot of security of supply and reliability of supply in the power grid. However, you need to have certain properties in place for these flexibility resources. So they have to have the trinity of quality, which means ramp rate matters, power level matters, and duration or energy matters. So this trinity need to be taken into account. And many of the sources cannot support this in order to provide this. Again, this is the reason why we have limited, reduced system service in place, like ancillary service, may lead to a blackout situation as we faced recently. If you accept and have some schemes in place such that load profiles are maintained, you have a lot of flexibility. Under this condition, you can do a lot of things. For example, carbon emission can be achieved by shifting loads, as been indicated on this slide. So you have spatial temporal shifting of workloads you can do in order to accomplish carbon savings a lot. So an example is this afternoon is a data center that we built inside windmills, right? And of course, we want to take immediate advantage of the supply of renewable energies this way. And the data centers have the purpose of AI running into the data centers. And so we're experimenting with that. I mean, this has some immediate advantages that, first of all, you can use the space. The wind towers are there anyway. They're very well cabled. They have, of course, power cabling. They have communication cabling in place. Then, of course, the towers can also be used as heat sinks, so another saving of energy in this context. But what's very important, we should not repeat the same mistake. We should negotiate a load profile with the energy providers very carefully. And this means we need to have, again, coming to the IETF or IRTF, we need to have some communication protocols in place such that the data center operator can talk to the energy provider and can also talk to their customers. And for that, we need something like green service level agreements where the customers, they might accept certain performance fluctuations, perhaps at a rebate, because then CO2 emission can be reduced. On the other hand, you need to have a clear contract with the energy suppliers with supply-demand agreements in order to fix the interface to them and the grid operators as well, such that load profiles are not distorted by all these operations, local operations, right? This is extremely important. I think this is the right place here at IRTF to work on this. Just to come to a conclusion of the talk about the market side of things. Now, this figure, which is from Germany, it's German text. Apologize for that, but anyway, I think the message is interesting to look at this figure. You can see that the figure tells you about the last 10 years what electricity costs in Germany. So you can see that we had taxes, which amounted to about 50% of the electricity cost for a very long period of time, very stable form. And then we have the electricity cost and the grid fees. What you can see from this figure here is that while the taxes made up for about 50% of the overall cost, we had somehow balanced electricity fees and grid fees, while 10 years back in time, grid fees were the lowest part of the cost. This has changed such that electricity fees have stayed flat or even decreased somewhat. But what is interesting to see in 10 years, the grid fees, they have doubled essentially, which is a quite interesting figure to look at. What does it mean? The grid fees is for building up the power grid or expanding the power grid, plus it's about this system services, ancillary service that they also need to be accounted for. That goes into the grid fees, right? So we're paying much more for grid fees now than we're paying for electricity, right? So the electricity approaches flat rate is getting less and less expensive. Now there's an artifact here that the electricity price skyrocketed because this is due to the Russian-Ukrainian war, that due to the cost of natural gas-fired power plants and the merit order principle that defines the clearing price for the electricity market. And of course, this is a real artifact that is, we should move it out of the equation here in order to understand the system much better. And as a result of that, taxes have been decreased in order to make up for this increase. So that's the last couple of years you can see this distortion. But the message to take away, grid fees have doubled while electricity costs have actually decreased over 10 years of time, which is quite interesting to think about, bringing us back to what I said before. The flexibility resources are key to everything, and we should not mess up with that, right? This is very important. We should, whatever we do locally should not mess up with the system behind it, because it just costs more carbon, it just costs more resources. Okay, coming to my conclusion. Yeah, power system and ICT, I hope I could convey that message, are increasingly interdependent. So now, of course, you cannot really distinguish it anymore. Talking about the smart grid, literally speaking, it becomes smart. So power system relies on ICT necessarily for critical services. I gave a few examples, there are many, many more. Of course, cannot cover them all. One example would be forecasting is ICT based, typically AI based on many cases. But ICT also relies on power. Of course, no power supply at all, worst case, blackout, but there are intermediate scales as well. If you have an emergency situation, then you be very careful what service you want to support. Now, the services are interdependent in a complex manner, so you have to be very careful that if you discard one service, it might not block another service, which could really, really happen if you're not careful in this context. Yeah, we could do a lot of things. Flexibility is key, really. We can use flexibility in many ways, but we shouldn't mess with the system. And yeah, and I think that's something I want to conclude here and start the debate. Thank you very much.
Thank you, Hermann.
Yeah, amazing talk, Debopam from Microsoft Research. I have two questions, or rather I want to understand your opinions on two things. First of all, you mentioned that grids are getting congested and there is a lot of curtailment happening online. And you also hinted at the possibility of deploying data centers at the wind farms, right? That is something that you are doing. So what is your take on that? Is that trend going to increase over the next couple of years, that we'll get to see a lot of smaller data centers getting deployed in the wind farms and running, a lot of workload? That's the first question I have in mind. The second question is about batteries, right? What I understand is the grid scale batteries are getting cheaper. And do you think there would be a significant adoption of batteries in the renewable energy farms and also in the grid, which could then act as a cushion and then deal with the uncertainty in power generation?
Absolutely. Hopefully I can remember all your questions. So, I mean, coming back to congestion, I mean, this is a really, really pressing situation, one of the most pressing situations at the moment, at least in Germany and across Europe, I think, where the TSOs, they work very hard on that and they are suffering a lot and they don't have a ready solution for that. But what we need is a congestion control algorithm that comes in place that helps the current situation, which is, I think, worst case in the sense that curtailment is very, very costly and a very rigid method. I'm convinced there are other methods in between. Because in the distribution grid, we don't have really complete state estimation. I mean, there's about the automation about 10%. So we don't know what's going on in the grid. And as a precaution, curtailment happens. So it's really, really, really costly effect. But with smart, intelligent congestion algorithms, I'm pretty sure we could do a lot.
So is there an opportunity to move closer to where the source of the power is and consume this otherwise curtailed energy at the source?
Absolutely. I mean, that's our project. I just mentioned the CACM magazine article that just appeared now in July 25. does exactly that, where we try to bring the load to the source of the power inside the wind cores, right? So we're doing that right away. It could do it with wind, with solar farms as well. Yes, that's the goal, because you can use this curtailed energy locally, right? And so it doesn't, there's no congestion to the grid for that, right? So you get this almost for free in a sense. So that's a good possibility. However, you have to be very careful that you're not messing up with the electricity system and the grid at the same time. So you need to respect the interfaces or the load curves. You need to pre-negotiate that in order for that to work.
Thanks. And the second question was about grid-scale batteries, whether you see that getting adopted.
Okay, batteries. Yes, batteries are very valuable. Batteries are a source of flexibility. They are a flexibility resource. You can use them, but you have to use them carefully. You can use them in a beneficial and non-beneficial way. I mean, again, electricity suppliers, and grid operators also, they complain about the misuse of batteries. For example, batteries are used on the market to buy electricity and sell electricity, but irrespective of the grid state, right? That creates havoc, and observably havoc. That's a big problem. But properly done, yes, you can use batteries as a source of flexibility in the general sense that's been introduced. Make a careful plan. Again, we're using network calculus for calculating the probability that all flexibility requirements are used by the battery, and the rest could be used as you like it, as long as you're not messing up with the power system behind.
Understood. Thank you.
You're welcome.
Hi, thank you very much for the very nice presentation. Very briefly, what do you think is the main bottleneck? Technical? Here.
Sorry.
Technical or policy and regulation? What should change first in order to move forward?
Oh, it's a chicken egg problem, I think.
Quick answer, please.
Yeah, I mean both, right? So we have both. There are regulations, and change of regulation is very small, but building up power grid is also very small. I think we should look for pragmatic solutions. I mean, as we did with the internet, with the IETF, moving forward, rolling out things, testing things that work, not waiting for the next 40 years to roll out an upgrade of the power grid. It takes just too long, and all the policies take long. So we have to live with what there is. I mean, good example, energy communities. Each individual is free to choose the energy supplier as the individual likes. If you're part of an energy community, you're messing up with everything you can mess up, because each supplier might be in a different balancing group. So you're moving energy from one balancing group to another. They both need to compensate by their flexibility resources, which is very, very costly, which is very CO2 intensive. Yes, this is a regulation which is really counterproductive in this respect. But there are many, many regulations. Yes, I agree.
Just very quick question, please.
Okay, so I think instead of, to help Dirk out here, I'm just going to ask a question that maybe you can help us understand later when you give your second half of your presentation of your work in the Sustained Research Group, which is when you talk about batteries, oftentimes I hear about batteries at the source of the electricity generation, or I hear about them at the destination. But like the internet, you could put your batteries, which are the queues, almost anywhere. And so I'd love to hear more, maybe later, about whether there's any thinking along queuing, putting your batteries in many, many more places in order to be able to handle the congestion in the middle of the network, the electrical network. Anyway, there you go. I don't know if we have time to answer or not, Dirk.
Yes, I mean, batteries could be of great use. Absolutely, if they're managed well. They could be counterproductive if not managed well. So there's no clear yes and no. It depends. But most likely, yes, you can make really good out of batteries, absolutely everywhere. But batteries are also limited in capacity. I mean, they're also expensive. There's also some environmental problems with batteries somehow. So it's not the holy grail. It's a good thing. And of course, the power system needs flexibility on all levels. I mean, the load side also provides flexibility. You can shift loads if the customers are happy with that, and that's much more sustainable. And so batteries are good. Everything matters.
Right, and then virtual batteries in the way of data centers or network data transmissions in order to soak up that excess electricity that would otherwise go wasted. So having things that can elastically sort of spin up is their discussion of putting them in the places where the congestion exists as well.
That sounds like a great topic for the Sustain RG meeting in the afternoon. So let's thank Hermann and also Harika and Henrik once again for their great talks. Thank you. Okay, and this concludes our meeting today. So thanks very much for attending and for all the good questions. If you have any feedback on this, please drop me an email. And I'm looking forward to see you again. Thank you.